Hello, hello, hello. Welcome to Lecture 2 of Equilibrium. We're going to talk about Le Chatelier's principle in shifting. Yes, Le Chatelier's principle. Le Chatelier's principle. Le Chatelier's principle. So you should be able to say it. So say it with me. Le Chatelier's principle. So if you can say it, you can understand it a little bit more. So when a system is at equilibrium and a stress is applied to the system, the reaction shifts to relieve that stress. I'm going to add and reestablish EQ. Now remember last time I told you EQ is the abbreviation for equilibrium? Such a long word, so get used to using that. This is based on the collision theory, and the collision theory needs to be explained using collisions, successful collisions compared to the opposite direction. So here's a sample equation, 2AB, blah, blah, blah. First thing I noticed, solids are not involved. Solids are not involved because their concentrations can't change. Okay? So remember, we're going to leave out solids. All right, stresses. Increasing concentrations. Notice it's concentrations, not amounts. Not amounts. Now, often it is amounts as well, but it's got to increase the concentration. That's why solids are not included. Solids are not included. Adding more A, I'm going to add this, will cause more collisions on A's side. So if there's more A's, it'll hit B more often. So more successful collisions per time than the opposite reaction. Adding ships away. Yay! Adding more D has no effect, as solids and liquids do not change concentration, so rates don't change. Okay, so remember, solids and liquids cause no solids and liquid changes do not cause shifts. All right, so decreasing concentrations, shift towards it. Side reactions are the cause. Look for a positive attracting to a negative. Okay, so a lot of times these will have charges on them. Okay, C has a side reaction with the compound your mom and removes some C from the system. The reverse reaction will have fewer collisions with C. Why? There's less C. So then the reverse reaction will be slower and the forward reaction. Remove shifts to replace. Remove, replace, add, away. Increasing pressure. If I increase the pressure, it shifts towards less gas. Pressure only affects gases. The system with more gases will have more gases collide, react, and change to non-gases. The number of gases includes the coefficient. Don't forget the coefficients. So when I look up here, I only have, over here I have 3 gases, and over here I have 1 gas. See how the coefficients matter? The P increase, if P increases the gas for the reaction above, it shifts to the left-hand side to reduce gases. All right, decreasing pressure shifts towards more gases. Decreasing volume increases pressure, and increasing volume decreases pressure. Adding heat shifts away from the heat term. Exothermic, hey, I remember that. Endothermic, hey, I remember that. Adding heat to the top reaction would have it shift left to remove the excess heat. Adding heat to the second reaction would have it shift right to remove excess heat. Most missed question. People think K changes all the time. The only thing that changes K is changing temperature. When heat is involved, shifting right increases K and shifting left decreases K. Examples, here we go. All right, here's my equation. I see a negative delta H. I remember that means that heat is going to be a product, so I'm going to put plus heat here. If I increase pressure, right away I know it's going to go to the side with less moles of gas. All right, so how many moles of gas do I have over here? I have 4. Over here I have 2. It'll shift to the right-hand side, fewer moles of gas on the right-hand side. Increase the temperature. That means I add heat. Add heat shifts away from heat. Backward reaction is endothermic, so it removes heat by shifting to the left-hand side. Increase concentration of nitrogen and hydrogen. Add shifts away. That'll shift to the right-hand side. There's left nitrogen and hydrogen on the right-hand side. Increase ammonia, just in case you couldn't figure out. Ammonia is NH3. Of course it is. So if I add NH3, is that what it said? It's add, it shifts away, so it's going to shift to the left-hand side where there's less of that. Let's see if my pen will grab itself now. Whee! New reaction. Oxidation of ammonia and the manufacture of nitric acid. NH3 gas plus O2 gas yields NO2 gas plus H2O gas. I'm emphasizing the gases here so I don't get tricked by solids or liquids. Delta H is negative 909 because it's negative. Heat goes on the right. Increase the pressure. What am I looking at? Moles of gas. Okay. Increase temperature. Away from heat. Okay. Left-hand side, away from heat. Increase ammonia and oxygen. You can do them one at a time too. It'll shift to the right-hand side. Increase concentration of nitrogen monoxide and water. If I'm adding stuff on the right, adding on the right, shifting away. Shift to the left-hand side. All right. Both these reactions can be catalyzed. The first with iron, I got to call. First with iron, the second with a platinum and rhodium catalyst. It is very important to note that the catalyst will not cause a shift in equilibrium. A catalyst will not cause a shift in equilibrium, will not affect K. It just gets to equilibrium faster. So it speeds up both. Okay, color shifts. So many times we try and figure out what's going to happen, whether it's going to become a lighter or darker color. Okay, so first of all, you will never have a pure color. The reason why is because there's never zero at equilibrium in an equilibrium system. Okay, so I can never have something be pure red. So if it can never be pure red, that means it's always going to be orange, right? Yellow and red make orange. So if it's redder, it'll be darker orange. If I'm shifting left, it will become yellow. It'll be lighter orange. If you add a specific color, that color increases a lot and then decreases some. For example, if I add CH3COH, it gets more yellow. Very yellow at first, then it will shift to red. So if I add 10 yellows, it will shift, and the final would be up 6. Okay, so my analysis of that would be if you found out that you won at the all-school assembly, you won $20,000. So if you won $20,000, would your spending go up for this weekend? Oh, yes, it would. But would you end up with on Monday negative money? No. So if you win 20K, you might go crazy and spend $3,000. And you're still going to end up plus 17K. Okay? So if you add something, it will still overall go up. If you remove CH3COO, it will shift to the right. Now, removing something without color doesn't matter for anything. It will shift to the right, so the red goes up and yellow goes down, and it becomes darker orange. Nothing ever gets to colorless. Equilibrium must have some of each. Lighter orange or darker orange is best, and that's it. We are done. Toodles.